Hello students, today we are going to learn about the next topic in the chapter 4, that is permeability of soils and seepage analysis. Coming to the next topic, it deals with the graphical representation by the flow net. What do you mean by graphical method? It is nothing but the flow at construction, which is most commonly used method. So the hydraulic boundary conditions which define the limiting lines and equipotential lines should be first identified and they have to be established. Later, a reasonably good flow net can also be drawn by the graphical method even with some practice. Some practice is required to carry the graphical method. However, for getting a good flow net, a lot of practice and patience is also required. So fortunately, the accuracy of the computation of hydraulic quantities such as the discharge and the pore water pressure will not depend much on the exactness of the flow net. So a reasonably good estimate of hydraulic quantities can be made even from a rough flow net. We have a procedure for drawing the flow net. It is divided into the following steps. First, we have to identify the hydraulic boundary condition. So the upstream bed level GPAK, which is shown in the figure, which is 100% potential line, and the downstream bed level, that is CFJ, which is a 0% potential line. So the first line, that is KIA, will touch the hydraulic structure and it is formed by the flow of water on the upstream of the sheet pile and the downstream of the sheet pile, and also at the interface of the base of the dam and the soil surface. So the last flow line is indicated by the impervious stratum, that is AP, which is shown in the figure. So after that, we have to draw a trial flow line, that is ABC, which is adjacent to the boundary line. The line must be at the right angle to the upstream and the downstream bed. So we have to draw ABC line in such a way that it should be at the right angles. So the location of the first trial line is determined from experience. So an experienced person will make a good estimate of the first trial line and subsequent work would be reduced. Starting from the upstream end, we have to divide the first flow channel into approximate squares by the equipotential lines as shown in the figure. These are the squares. So the size of the square will change gradually. Some of the squares may however be quite irregular. Such squares are known as singular squares. We can extend downward the equipotential lines forming the sides of the squares. This extension will paint out the approximate width of the squares, such as the squares which are marked as 1 and 2. Other sides of the squares are set very equal to the width as described or determined above. Later on, the irregularities are smoothened out and the next flow line DF is drawn, joining these bases. See here. This is the next DF. Is drawn joining these bases. While sketching the flow line, care should be taken to make flow fields as approximately squares throughout. We have to make, like assuming these are the squares. Later on, the equipotential lines are further extended downwards and one more flow line is drawn, repeating the step 4. This is the one more flow line. Again, it is forming the base of another square. If the fields in the flow channels are inconsistent with the actual boundary conditions, the whole procedure is again repeated after taking a new trial flow line. Thank you.